In this video we want to talk about business process management. Now this is an important topic. It crops up in several modules and it crops up right throughout our study of business as well. It's a term that's often used and we should have some understanding of what's meant by business process management. So business process management is an approach which aims to ensure that a workflow is more efficient, effective and compatible with internal and external environments. It tries to ensure that the workflow is efficient and effective and it's compatible with the internal and external environments. In other words, there is no mismatch between what is being undertaken and what is required. And what has been undertaken is being done efficiently. The role of BMP, of Business Process Management, is to assess, control, monitor, evaluate and improve business processes. So it casts, a critical eye on processes within the company and tries to assess what is the best route, what's the best way of performing these functions, or what's the best route to follow under certain circumstances. So it assesses, it controls, monitors, it checks all the time and evaluates what's the outcome, what are the inputs, what are the outcome, how efficient is the system, and makes recommendations accordingly. An efficient process will enable the organization to meet their objectives and gain competitive advantage. So clearly, business process management is a tool, if you like, a process that enables the organization to monitor its own activities and to improve the efficiency of those activities so as to gain competitive advantage. In other words, to secure its position in the market. Now, business process management relies on the following considerations. Are the processes meeting customer needs? Clearly, it's essential that the processes do meet customer needs. It's the customers who buy the product, and if the customers are alienated or don't like the product, then the company will fail. So it's imperative that customer needs are put first and that the business process management system recognizes the customer needs and attempts to meet those needs. How should a business process be organized to achieve efficiency and effectiveness? There may be alternative ways of performing a particular task. It's the job of the business process management team to isolate out the one which is most effective and most efficient, the one that's going to get the job done with minimum input, or if you like, maximum output for a given input. It's the same thing. It measures the efficiency of the process. And what tools and techniques will be used to evaluate and monitor a business process? In other words, the business process management team must work out how should processes be monitored. What tools or techniques should be used? Should the process be monitored every day or every hour or every week? How should it be monitored in terms of its output, its inputs, its running time, its productivity calculations? How should it be monitored? What is the benchmark? How has it been set, and how should the monitoring team look at the task? Now, business process management mainly revolves around the following activities. Activities must be organized around outcomes, not tasks or people. So the activities don't look at the people who are, say, employed within the plant, and they don't look at the tasks that the people perform. Instead, it looks at the outcomes. It looks at what has been produced. In a sense, how it got there is almost irrelevant at this stage. It looks at the outcomes and sees if the outcomes meet the criteria that have been set out for an efficient and effective system. And if the outcomes meet those requirements, then in a sense the tasks and the people must be going about their activities correctly. So it's not people-centered or task-centered, it's outcomes-centered. It's designing, correcting and testing processes before automation. It looks at what needs to be done, what's the best system to use for, let's say, production. How should the operations be automated? What are the sequences? How long does each one take? What's needed in terms of human inputs? Establish tasks and establish ownership and allocate resources and activities. Establish tasks. What needs to be done? Who needs to be involved? Where in the process do the people need to be involved? Look at the various tasks that are required, and then make sure there is a clear designation of tasks. Who owns the task? Whose job is it to perform this particular task? And then make sure that there are sufficient resources allocated to enable the activities to take place. So it's looking at the overall tasks, looking at the overall outcomes, and ensuring that the tasks are correctly configured and allocated to appropriate personnel. Processes must be standardized throughout the organization. This minimizes risks and errors. So look at the processes and try to standardize them so that there is less intervention required and less piecemeal adaptation of work. So the employees, the workers, don't have to get involved and patch up work or try to fix it whilst the whole system is running. So try to standardize. It'll minimize the risks and errors so that a standard product is running through. Existing processes should enable continued improvement. So look at the existing processes and always look at the existing processes critically to ensure that the processes are optimal, that they are the best design and the best implemented. But there may also be room for improvement. There may be the advent of new technology that's come on the market, or perhaps additional training for the operators would improve efficiency at certain points in the process. So it's looking at the processes to enable continued improvement, but it's looking at the processes critically to ensure that at all times the whole system is under review, and at all times intervention points may be identified for improvement. Business process management is a continuous activity and can be viewed as a process life cycle. Now, you'll see from other classes on the course what's meant by the life cycle, and you should be familiar with this by now. So in this case, it's a process life cycle. It's looking at how the process runs from start to finish, and in a sense the process, there's a learning phase as the process is first introduced. Then there's the maturity phase where the output is very high and the process is running smoothly. And then there's a decline phase as the capital is running out. The machines are getting older or becoming more obsolete or have been replaced on the market by new technologies. So we can see it as a process life cycle. But in the context of what we're doing here, we can just see it as the design phase, the modeling phase, the execution phase, the monitoring phase, and the optimization phase. Now, this type of approach to the life cycle may seem a little strange to us because we can identify it, as I said earlier, in terms of the bedding in of the system and how the system becomes up to speed, how it becomes most efficient, how it optimizes, and how it can decline with the advent of new technologies and so on. But here we've got an approach to the business process management which is based on the design of the product, modeling, execution, monitoring and optimization. And in the sense, it's the same as the life cycle in the sense that all of these various stages have to be undertaken. And at the end, after optimization, there is in a sense nothing, just waiting until the system is superseded by a new system. So we have various stages, and perhaps that's a better way of putting it, various stages in the cycle, from design, modeling, execution, monitoring and optimization. And we're going to spend a little time talking about each of these. The design, modeling, execution, monitoring, optimization. And I suppose the last stage after optimization is back to design. So we can see it in this way, that there is a constant need for design, if you like, a constant need for intervention and critique of the existing system. Out of the design stage, it should be modelled to see if it works. This may mean making a prototype, a scaled down version of the system, and seeing if it runs, or it may be running it through on a computer using a CAD, a computer-aided design package, perhaps, to see if all the parts fit together and if it will do what was assessed. Obviously, there's considerable expense in modelling and trying to test out the system before it is fully implemented. But there again, it's important to do this because the full system may involve significant investment expenditure, and it may be a lot cheaper just to see if it runs on a computer, or if it could be modelled, perhaps physically modelled on a scaled down version, to see what are the issues. And of course, after the modelling stage, it's executed, it's actually put into place, and the investment is made, the system is established. Then it's monitored, and of course the process of optimization runs right throughout to ensure that the system is running smoothly and running at peak efficiency. The design stage, well, this stage involves the analysis of existing processes and redesign in order to make the process more efficient. So at the design stage, it's really based on a criticism of the existing system, if there is one. If there isn't one, then it involves a lot of research and a lot of discussion internally with technical staff, with managers, with the marketing personnel, to ensure that the product to be produced is of a certain specification and that the technology and the processes to be put in place are compatible with that and meet that requirement. So the design stage involves the analysis of existing processes, if they exist, and the redesign in order to make the process more efficient. The design includes factors such as workflow efficiency, employee roles and responsibilities, standard operating procedures, and the system itself, how the system integrates and works one part with the next. So the design stage is very important. It tries to gauge the workflow efficiency. It tries to estimate the efficiency and what is the most appropriate layout for the system. The employee roles also, what is expected of the employees and what skills and competencies must they have in order to meet their tasks, their assigned tasks. And is it possible then to standardize and ensure that there is a running system which has a standard procedure, making a standard product, and it's standardized across the whole system so as to minimize errors and rejects. So the design stage is very important in trying to determine these factors. The purpose of a good design is to reduce errors over time. Improvements could be human to human, human to systems, or system to systems. Human to human means that there is adequate training amongst the staff so they're able to communicate effectively within that particular system. They're able to communicate effectively, ensure that their requirements are clearly communicated, and that the nomenclature, the expressions, the terminology that's going to be used is standardized. So they know exactly what they're talking about. They talk about different parts of the machine or different tools. There is a standard terminology, a standard vocabulary that they can use, so there is no confusion. That's human to human. It's also human to systems, making sure that the humans and systems can interface, that they can link, they can connect, and the humans can perhaps alter some part of the system, can modify it, can update it, can intervene and regulate the speed or the efficiency or some aspect of it, or replace a component. The system must facilitate humans. It must be designed, the machinery and the technology must be such as to allow human intervention, if for no other good reason than remedial action to fix something that's gone wrong. And of course, systems to systems. It's important that each distinct function within the system links with the requirements of the next part of the system, and also links with the previous part of the system. So the whole system can be seen as integrated. It's different aspects of the system linking to different aspects of the system. So there's a continuity right from start to finish. Modeling. Well, modeling is referred to as the testing phase. It's a draft model or design. It's deemed to be very important because this may throw up issues and problems that perhaps would otherwise have been missed, which could be catastrophic for the investment and for the whole project. So it's important that issues are identified early and corrected early. The process is thoroughly evaluated before it reaches the execution stage. It's important that the modeling process enables thorough testing of the whole system, so that there's no wasteful expenditure in terms of full-scale expenditure on the system. They're not going to buy machines and buy technologies which are unsuited to the requirements. The modeling phase must iron this out. It must demonstrate what works well and what does not work well, so that management has a clear understanding of what they're getting. It should evaluate possible scenarios and assess the process suitability. So at the modeling stage, it should be even possible to stress test the whole system to see what are its maximum what's its maximum capability and what parts are likely to fail when run at a high level of activity for a sustained period. So the modeling process is very important. This is the one which will give the management confidence to make the decision to make the full-scale investment, should the modeling experience be positive. For example, what if there are changes in rent or raw materials and the introduction of new machinery? So just looking at the layout, perhaps in the modeling stage, how much of the plant will be taken up by the new technology or this particular project? And look at the cost, the overhead costs of just having it there. Look at the way it uses raw materials and where the raw materials are entered into the system. and how does it cope with perhaps raw materials that are perhaps not 100% good quality? Will this lead to a failure of the system? Because sometimes metals, for example, may not be 100% good. And look at the ability of the system to be upgraded. Look at what's needed to upgrade the system if new technology comes on the market. So it may be that the whole system will be in place, but parts of it from time to time will be upgraded by better machinery. And if the company wishes to remain competitive in the marketplace, it may have to upgrade its machinery. Is it modular in the sense that part of the system can be taken out and a new part put in, and it seamlessly meshes with the other parts that are in existence? Because if that happens, if that was the outcome, then that would be desirable. But if the new technology was incompatible with the overall system, then they could be making an investment which within some period of time will become obsolete. But the whole system will become obsolete, and that would be much more expensive. Execution. Well, execution is the automation and development of the process. For example, thorough software tools and through software tools, I should say, and human intervention. Execution is putting it into place, actually doing it, and making sure that the human component is trained and ready to enable this to happen, that there is fluency in the use of the technology, fluency in the use of the software. Points of intervention are clearly demarcated so that the workers know where to intervene and what to do when they intervene. Health and safety issues have been addressed. Design within the plant has been worked out and optimized. So everything should be, in a sense, worked out from the modeling stage. But now, in the execution stage, this is when the system is put in place. The improved process is launched and ready to use by the end user. This is when everything is ready. It's been delivered, it's been fitted together, it's been tested, and the staff are trained. So in a sense, everything is ready to go. That's when we'd say the execution stage has been done. The execution is the practical analysis of the process and its suitability for business purpose. It's based on the modeling work. It's making the decision and finally making the investment and receiving the technology, putting it together, and now in a sense the organization has made the investment, so if you like, the commercial decision has been made, and it's got a green light to go. The order has been placed for the technology. Now it's been received, bolted together, the staff are trained, so in a sense everything is ready to go to the next level, which is engage in production. The stage should be error-free, and all scenarios and tests have been analysed in the modelling stage. So as I said, this particular stage really relies on just the decision to make the investment. Management having acquired all of the knowledge from the modelling stage and having investigated the market and what the competitors are doing and so on, customer requirements and so on, the management make the decision, and this is the execution. Now put it in place and get it ready to move. Monitoring. Well, monitoring of process and its success. This can be achieved through process reviews, performance indicators, process performance. So monitoring is really setting up standards through which the process can be checked to see if it is optimized, if it's running according to expectations. There could be process reviews. There may be feedback from the employees working with the process, from the line managers and perhaps the departmental heads and so on, about how the activity is running, how the system is running. And there should be some performance indicators. There should be some expectation about how well the system should run, what it should produce in a given time period. And then this would enable benchmarking, if you like. It would enable some sort of reference point to be set for the system, and if it achieves it, it's running well. If it's not, then intervention may be required and some tweaking required. So it's looking at the performance of the system. Monitoring allows for collecting information, tracking the processes, reviewing statistics, and making future recommendations. So it's looking at the various sources of information and looking at what is required for an optimal system. The various process measures may be used for monitoring. Cycle time, how long does it take for the raw material to be converted into the final product on the system? How long does it take to move through the system? And what are the number of defects associated with the production process? Perhaps defects per run, or it could be defects per day. It depends on how standardized the system is. But look at its productivity, if possible. What's expected through the system on a given day or in a given time period, and what actually happens. It's a measure of how well the system worked on in a particular time slot. Benchmarking is quite important to understand what should be reasonably expected from the system, and then comparing with what actually comes off. It could be there's some policy like, say, Six Sigma being applied in the organization in terms of rejects. So the system is intolerant towards rejects. It doesn't want rejects. It runs at with peak efficiency and peak quality in terms of the output at the end. It could be that's the case. Now, in which case, then the system should be not just adequately monitored and maintained, but it should have appropriate intervention points to see where likely errors are going to occur, and these should be fixed and maintained regularly. So there should be intervention on the part of management to ensure that the system is given, in a sense, every opportunity to meet the high quality standards that are set. It may not be exactly Six Sigma. There might be some other measure of quality that's been assigned to the system. But really it depends on the product being produced and the technology that's been employed, and the importance of quality in the overall production process. Optimization. Well, information from execution and monitoring is gathered regarding the process. So the system enables the collection of data, and the data can be processed into information which then sheds light on how well the system is working. And it may be that all of the system is working perfectly well. It just needs to be optimized. It just needs tweaking to ensure that there is better continuity from one stage to the next, or that unnecessary interventions are cut out or eliminated, so that the system is allowed to run smoothly from one part to the next. So optimization is tweaking the system to get maximum efficiency from it. It identifies the process strengths and weaknesses and potential opportunities. So the whole optimization process, this idea of intervening to maximize the throughput and maximize the efficiency of the system, it looks at the strengths of the system, the capability of the system, but it also looks at areas that are likely to break or likely to run in a suboptimal way. And it should offer explanations as to why that is the case and see if there's some fix or some patch or some new component that can be added to reduce the weakness, to eliminate the weakness if possible. And it should also identify potential opportunities for further efficiencies, perhaps adding additional processes which could be automated, which would add or speed up the system. So it may be that the system is configured to run at a certain pace, but one particular process runs slower, which means the overall system runs at that speed, at the slower speed. So is there some way of tweaking or dealing with that one aspect of the system which is running slower than the rest? Because if that can be fixed, then the overall performance of the system will be greatly improved. The optimization process should also make recommendations and solutions to implement into the design phase. This restarts the process cycle. Well, optimization is when there's experience of using the system, and the experience from using the system indicates what's going well, what's not going so well, what needs improvement, and how can the system be changed and modified and improved. And this, of course, can then be fed back into the design stage, because presumably there will be a life cycle to the whole system and it will phase out. And at that stage a new system will be required. But the new system will not be starting from scratch. The new system in the future will have the information, the knowledge, the experience of running the existing system. And the requirements of the existing system in terms of optimization can be fed back into the design stage, so that the whole design and modeling and implementation and so on, all of that can start again, but this time based on experience from the existing system. Recommendations can be related to new methods for cost savings, new technology, improved process design, better business values, and so on. So all the time the optimization process is looking at the efficiency of the systems, looking at the routines that are being undertaken, looks at the shortfall of the system, the weaknesses in the system, and it makes recommendations all the time in terms of what can be done to improve the existing system and what changes can be brought about, what design changes for the future should be borne in mind. And it's constantly feeding back information, some of which can be enacted straight away. The management can adopt the recommendations straight away and intervene with the existing system and make improvements. Some, maybe long term, will have to be fed into the design stage for any future major reinvestments in this area. So that's our discussion of business process management and the importance of business process management. It's a topic that arises a lot within the business and management literature, and it's one that we should be familiar with. But that's all we're going to deal with here, so let's leave it at that and say thank you for watching.